Hello and welcome to this course, Programming AutoCAD .NET API using C# and SQL Server. My name is Arnold Higwit and I will be your instructor. In this course, I will walk you through the process of connecting and integrating AutoCAD and SQL Server Database using C# programming language. We will start with creating and preparing our database and tables using SQL Server Management Studio. Then we will begin developing our plugins functionalities, starting with the loading of lines, Mtext, lightweight polylines, blocks, with and without attributes into database. Once we have our AutoCAD data in database, we will continue to develop the methods to retrieve records from database and recreate those objects in AutoCAD. During the data retrieval process, the object's record ID from database will be attached to the AutoCAD object's XData as our identifier that will serve as a link between AutoCAD and SQL Server. Now that we have established the link between AutoCAD and SQL Server, our next task is to develop the methods to update existing records from database with any changes that were done in AutoCAD. And finally, we will develop all the methods to delete records in database from AutoCAD. The deletion process will be a soft delete, which means that we are not getting rid of the database records, but we will mark those records as deleted instead. This way we don't lose the records and keep a historical information by providing the date and time when the object was deleted. By the end of this course, you will have a working plugin that provides all the functionalities to interact with the SQL Server database. This is a very exciting course, so please join me in this journey, and I hope to see you inside. Hello and welcome to introduction section of this course. In this section, we will discuss the topics that we are going to cover. The first one is what will you learn from this course? Then the next one is who is this course for? So what will you learn from this course? The first thing that you will learn is about AutoCAD .NET API programming using the C# programming language. Then the next one that you will learn is how to use the Windows form, which means that you will be using that to create your own user interface so that you can call those methods that you have developed in your plugin. And then the third one is you will learn how to use XData. You will learn how to attach a value into the object's XData, and you will also learn how to retrieve that value so that we can link that into our SQL Server database. And then the next one is you will learn how to connect to SQL Server database using the ActiveXData object or ADO. Then you will also learn the basic database operation like the create, read, update, and delete. Or we have here the acronym called CRUD or CRUD using SQL Server database. Then who is this course for? This course is primarily meant for AutoCAD developers with some programming background using Autolist, VBA, VB.NET, C#, and Object-ARX. But this will be more beneficial for those who know how to program using C# and or VB.NET. This may not be appropriate for the beginner developers. So I suggest if you are new, you can check out my other course, which I offered a beginner course for C# programming in AutoCAD .NET API. And then this course is also meant for developers in general who want to learn about AutoCAD .NET API programming using C# with SQL Server database integration. Welcome to section 2 of this course, Tools and SQL Queries. In this section, we will identify the tools needed for this course. The first one is AutoCAD. You need a full version from 2014 or higher. The next one is Visual Studio 2019 Community Edition. We will use this to code our C# program. The next tool is the SQL Server Express database. This is a free version of the database with a maximum capacity of 10 gigabytes. This is not a full-blown database, but it is good enough for our requirements. The next tool is SQL Server Management Studio, or SSMS. We will use this to write our SQL statements as well as interact with the SQL Server Database. And finally, we will have a quick introduction and demo of basic database operations. We will learn the CRUD or CRUD, create, read, update, and delete operations. And that's it. In the next video, we will start downloading these tools. I'll see you there. The first tool that we're going to download is the Visual Studio 2019 Community Edition. The download URL is this link here. However, you can also Google it and then just type in Visual Studio 2019 installer. So if we try that one now, Visual Studio 2019 installer, and it should give us the top one here as the result. So just click on this link and we are presented with different options here. So currently there is already a release candidate for version 2022, but for us we will just be using the 2019, and this is the community edition, which is the free one. But if you have professional or enterprise version that's already installed, then definitely you can use that. You don't need to download it. So just click on this free download button here, and it should download the Visual Studio Setup.exe. So just click on that and then follow the download instruction. It's very straightforward and you should be able to install it without any problem. Okay, so that's it for this video. The next tool that we're going to download is the SQL Server Express Database. So the download URL is this link here, but you can also Google it with the SQL Server Express download keyword. So if we try that, you can just search for SQL Server Express download and it should give you this result. Just click on the top one here, and this is the SQL Server download page. At the bottom right, you have here the Express version. So if we look at this description here, the Express is a free edition of SQL Server, ideal for development and production for desktop, web, and small server applications. So just click on download and it should download for you the installer. Yeah, you can just resume it if it failed at first, and it should give you the installer. So just open it and follow the instruction, the wizard step-by-step instruction, and you should be good. One thing to note here is that when you are installing it, make sure you select the mixed authentication that has both the Windows authentication as well as SQL Server authentication. So you just choose that option and the rest should follow the default installation instruction. Okay, and that's it. I'll see you in the next video. The next and final tool that we're going to download is SQL Server Management Studio, or SSMS. So we have here the URL, or you can just Google it using the SSMS download keyword, and it should give you the result here. So if we try that, just type in here SSMS download. You'll be having this result here, and just click on that, and we have here the link. So just click on this free download here, and it should download for you. It's quite big with a size of 653 MB. It will take a few minutes, but once it's done, then just install it, and that's it. It's very straightforward. So once it's installed, we should be ready for the next topic. I'll see you there. Our next topic is about SQL queries, or SQL queries. We will have a quick introduction as well as some demo. So the first database operation that we're going to learn is the SQL insert statement. When you speak of insert, it's just basically inserting a record into your database table. So we will have a hands-on demo on this operation that shows something like this. We will perform quite a number of basic insert statements so you can learn how it is being used and how easy it is to compose a insert statement in SSMS or SQL Server Management Studio. Then the next one is we're going to learn how to use the select statement. So selecting statement from database table is basically just providing the database with a query to select what are the columns or what are the records that you would like to include in your select statement. And again, we will have a hands-on demo that shows something like this. So we will also be performing similar select statements with different filter criteria. And the third one is SQL update statement. So when we speak of update, it shows something like we are updating an existing record in our table. So whatever records that fits in to our filter, to our condition, will be updated accordingly. Okay, so we will have these update statements quite a few times, and you can see the different ways to update a record. And finally, we'll learn about the SQL delete statement. So again, deleting the record in a table is simply issuing a delete command, delete from the table, and then you specify your condition or your filter criteria. And we will also have some quite number of delete statements so that you can understand better how to use that in your database. Okay, so that's about it. In the next video, we're going to have a demo of the insert statement. I'll see you there. Let us now fire up our SQL Server Management Studio. And we are prompted here to log in. You can either use the Windows authentication or the SQL Server authentication. So during the installation, you might have been prompted to enter a password for the System Administrator or SA account. So if you want to use this, you can just type in using your password, the one that you created during the installation. So in our case, I'm just going to use the Windows authentication. Alright, so in this Object Explorer, we can see the databases. I have here a CAD-DB, which we'll be using for our project. And if you expand the tables, we have a number of tables here. We have 5 tables. In our case, for this demo, I'm going to create a new table so that we are going to start from scratch. So you can just right click on this table and then new table. And I would like to create here an ID. And this will be our primary key. And I just make this as an integer. So you can choose from this drop-down list of data types. And allow nulls will not be allowed. Nulls will not be allowed. And we are going to set this as primary key. So right click on that and set the primary key. And there's one more thing that I would like to change here. If you check the identity specification, you have the option of setting it to yes or no, which means that if you set this to yes, the value of this ID will auto increment. Every time you insert a record, it will provide a unique value for you sequentially. And it starts from 1 with a seed of 1, which means that it just increments by 1. So we will keep it yes with 1 identity increment and identity seed of 1. So we're good with the first column, which is the ID. Our primary key, you can see here the key symbol, so that denotes that it is the primary key for this column, unique value. And next we have to add here, let's say just the first name. We'll make this very simple, and let's just choose a varchar 50, And in this case, I'm not allowing this to have a null value also. That's why I'm going to uncheck that. And the next one here is last name, also varchar 50. This means that we have a maximum of 50 characters that we can store in this column. Okay, and we are going to allow null values also. And finally, the last column is let's just create an age column, and this will also be an integer. Okay, and this one we will allow null value here. That's fine. So if we save this table, let's just call this as person. Okay, and that's it. So now if we refresh our tables folder, we now have a person table with all the columns that we have created. Okay, so now let's learn about inserting a new record. So in this case, we have to create a new query window or a new query. Just click on that new query and you'll have a new query here. So when we speak of insert, again, it just creates a new record in our table. So first, let's just select asterisk from person. This is our table. Currently, no record here. Okay, so we will just leave this select asterisk from person so that we can examine if our insert statement have been successful. So the insert statement only requires insert into the table name, in our case person, and you specify here the column names that you want to insert value into. So in this case, I have here the first name and also the last name and the age. By the way, there are many different ways to insert into a table using SQL queries, and we will learn that other options in the next a little bit later. So we have here specified the columns that you would like to insert into. You might notice that I did not specify the ID because, again, during the definition of this column, it is already automatic, auto increment, so we don't need to specify that. Next, we have to provide the values. Okay, and let's say we put here John and Doe, and the age is 25, for example. So in here we have enclosed all the string values with a single quote, while the integer we just provide the number. No need to provide the no need to include in a single quote. So these are our strings, okay, or varchar. So if we highlight this and execute, now it says one row affected. So if we now select our table, we now have one record here. Okay, that is one way of inserting a record into a table. You might notice here that I have capitalized all the reserved keyword in SQL statements, while the rest are like a camel case or proper case. Okay, so these are all the keywords in SQL Server, and this is the select. We will learn more about this in our retrieve or read part of the database operation, but for now we'll just use this so that we know that our insert statement worked properly. So there's another way to insert a record into tables. Let's say we copy this over and I change this to Jane and Smith. and age is 26, for example. And let's say we have more than one record to insert. You can either do this and copy multiple times the insert statement and change the name here. Let's say Jane to Smith 28, for example. Or you can just copy this and separate them by comma, and it will be inserted the same way. So let's say we have here another record, Mark Williams, for example, and age is 30. So now we have 3 records. Okay, so if we run this, it shows 3 records affected. Now let us select again. We now have 4 records inserted. Okay, so notice the ID, it just keeps on incrementing. So those are the insert statement. However, you can also perform an insert without specifying the column names. So let's say inserting without column names. This is, by the way, how to comment in SQL Server. SQL Server Management Studio, which means comment is not considered as executable line of code. So let's say we now have to insert into person, and then we specify the values right away. Let's say John Wick, age is 33, for example. See that? Regardless of you provide the column names here like this or not, for as long as you match the number of columns and the records that you are inserting, then it will be accepted. So let's try this. 1 row affected. So now if we select, we now have here, right? However, if let's say this one will have an error. If let's say I copy this and then I add here another value, let's say 32, and if I insert this, it gives me an error, right? Because the number of values does not match the columns that we are inserting into. If we specify this one here also, let's say we put this one here, and it will give us a different error. In this case, it's just giving us a different error, but it's actually saying that the number of values does not match the columns that's been specified. So if we run this, it gives us a different error. It says there are fewer columns in the insert statement than values specified in the values clause. Which one here? This one here. The number of values in the values clause must match the number of columns specified in the insert statement. That's why. Okay, so in order for that to work, you have to make sure that you have the same values here. So again, those are the different types of insert that you can use in your code. There are other ways to perform insert that's coming from, let's say, one table to another, but I will not go through that, as this is more than enough for our requirement. So now you should know how to insert a value. It's very simple. Insert into, then specify the table name and the column names, and then values, specify the values. If you have multiple records, specify the values once and just separate all the different values with a comma. Okay, and you can also insert records without specifying the column names, provided you know the number of columns that you are inserting into and you have the correct values in your values clause. Okay, so that's it for the insert statement or the create operation in the CRUD acronym. So in the next video, we're going to learn about the read or select. I'll see you there. Hello and welcome back. In this video, we're going to learn about the select statement or the read part of the CRUD acronym. So let's continue working on the same query that we have started earlier. So in this case, we're going to learn about the select statement. Okay, we have already used the select statement from the earlier video. So that's just how you do the select. If you want to select all the columns, just specify asterisk and then from which table, from person, and you get all of these records. There are also other ways to do the select. For example, you have a table that has hundreds of columns and you don't want to select everything every time. So you can specify the column names only that you want to retrieve. By the way, just to mention here that the SQL statements are not case sensitive, which means that you can use this. Let's say select ID, first name, last name, age, from, person. Okay, so you can do this and it gives you the same number of columns. So again, if you are only interested in ID, for example, you just specify the ID and it just gives you the ID. Now if let's say you want to have the ID and the first name, then you can just do that, same thing. And if you decide that you need the last name, then just add the last name and select, and it gives you the whatever column that you specify here. And if you decide to have the age also, then you can do something like that. Okay, very straightforward, very simple to use. All you have to do is issue the select and then the column names and then from person. So again, although SQL Server SQL statements are not case sensitive, I would still follow the best practice to make the keywords capitalized just to distinguish them from other statements in your SQL queries, other column names, for example, or table name, for example. Okay, so this is just selecting everything, basically, something like this from your person table. However, you might not always wanted to select all the records. Let's say you have here thousands of records or even millions of records. You don't always execute this select statement here. You need to have some kind of filter. So for example, we are going to select everything from person where, now this is not the where clause, this is basically the filter, where ID equals 1. Alright, so in this case, it just gives you one single record, only the record that has an ID of 1. So you can do this, and actually this is the better way to perform a select. You might not experience the latency or the response time because we only have very few records. But if you are dealing with a big database with millions of records, then selecting using the asterisk might impact the performance of your application. That's why it's always good to have a where clause. It's a filter. And let's say you can also filter not only on the ID but from other columns. Let's say from person, where first name equals, let's say, John, something like that. But it is advisable to filter based on the column that is indexed so that it's faster. All right, but you can do this too. There is no stopping you from doing that. Or you can put here age equals 25, something like that. Okay, and also you can specify more conditions, more filter criteria. Let's say select asterisk from person where ID is greater than 1 and let's say first name equals John or Jane. You can do that, and if you execute this query, it gives you this record here. All right, so if we select everything, we have here 5 records. If let's say I would like to select those persons with last name has an S on their last name, so you can do something like select asterisk from person where let's say ID is greater than 1 and last name like, you can do that, and then specify here the wildcard character, let's say S, using the percentage sign, which means that if there provided that there is an S either in from within this text, then it should be part of the result set. So if we execute this, now all of those last name with S in their last name, like Smith and Williams, are all returned, and also they have an ID that is greater than 1, right? So you can use these combinations, and you can have more. If you learn more about the advanced select statement, then there's so much more you can do, like those aggregations, having clause, and so much more. But for us, this will be good enough knowledge to retrieve our AutoCAD objects, for example, from database. Okay, so again, just a recap: for select statement, you only need basically 3 components. The first one is using the select statement, of course, and then from the table name, and then you can specify here the ID using the where clause as your filter, and if you decide, you can further refine the filter or add more filter into your statement, into your where clause statement, by using the end. Okay, so in the next video, we're going to learn about the update. I'll see you there. The next database operation that we are going to learn is the update statement. So let's start with the simple update statement here. So basically, when you say update, you're just updating the existing record in the table. If you want to make some changes on the value, then you have to use the update statement. Okay, so let's say we have to update the person record. So you have to specify update person, then set the value, what particular column you would like to update. So let's say the age equals 25. Now you have to specify where ID equals 1. This is our filter again. So before we execute this, let's just select everything from the person table so we know the record that we are trying to update. So in this case, we have here 5 records, and I would like to update the first record where ID equals 1. Let's change this to 30, for example. Okay, so as expected, we shall be updating this to value 30 because This is selecting only this particular record and updating the age value from 25 to 30. So if we run this, it says one row affected. So if we select everything again, now the age becomes 30. Okay, so this, I would like to point out one thing here that is very, very important. You have to make sure that you have the where clause. If you don't have this and you just update person and set the value, let's say the age, all of the records will be updated. So all of the age column will becomes 30 because there is no filter. So this applies to all, and it's very dangerous. All right. So if let's say we run this and see the effect, we have 5 rows affected. And if we select, now they all have the age 30. And that is a very, very dangerous operation. That's why you should always provide the condition, the where clause, the filter, so that you are certain that you are only updating a particular record and not all. Because if you accidentally use this update statement and you have enough access rights into your database, you might cause some really serious problem there. So you have to make sure that you have the where clause, and you can even specify an extra filter so that you are certain that you are only updating that particular record, like John. So let's say we put back the age of John to 25. So where ID equals 1, although this is sufficient, but there's no harm to add extra filter if you so desire. But this is more than enough for us. This should be good because ID is unique anyways. So let's run this, and one row affected. And if we select again our table, it brings us back to age 25 for John Doe, right? So again, if you would like to perform an update to a certain group of records, so you can still apply the same thing, the same filter as we have done here in the select. So update person, and let's say we would like to set the age equals, let's say 24, where ID is greater than 1, and last name, you have your last name, like the wildcard S. So all those last name that has S in their last name and ID is greater to 1 will be updated with the value of 24 for their age. Okay, so 3 rows affected. If we select again, now they are all 24 here for Smith, Jane Smith, Jane 2 Smith, and Mark Williams. Okay, and also you can update multiple columns. So you can do something like update person and set, let's say, age equals 32. Then let's say the Jane 2 here, the first name is, it's not Jane 2, it's, let's say, Linda, for example. And then where ID, if you know the ID, equals 3, and that's it. That should be sufficient. So this particular record will be updated with the age of 32 and the name of, first name of Linda, right? Let's try that. One row affected, and now if we select again, now we have here Linda and age 32. Okay, so just like that, all you have to do is issue the update statement and the table name that you would like to update, and specify the columns that you want to update, separated by comma, and then you specify the where clause, the filter. So let's say you don't want to use the ID, you can specify more filter criteria. Let's say update person, set, let's say age equals 41, where let's say we change this John Wick to 41, where first name equals John. Okay, but since we have two Johns here, then we can add another filter, like last name, for example, equals Wick, which means that we are only interested in updating this record here because this is unique in all our records. So the age of John Wick will be changed from 30 to 41. One row affected. And if we select, we now have here age of 41. Okay, so that's how you use the update statement. Very simple and very easy to understand. In the next video, we're going to learn about the delete operation. I'll see you there. The final database operation that we're going to learn is the delete statement. So let's learn about the delete statement here. So again, the delete statement, as the name implies, means to delete record or delete records in the database table. So the syntax for delete is delete from, then the table name. Okay, so when you are deleting from a table, you have to make sure that you have the where clause. Same with the update, because this particular statement here will wipe out the entire table. It will delete all records in your person table. That's why it's always advisable to provide the where when you are using the update or delete statement, unless of course you really intend to delete the records from your table. So if I specify here delete from person, let's say we would like to delete the record number 5 here, where ID equals 5, and it will just delete this single record here. Okay, if we execute that, and now we have one row affected, and if we select asterisk from person, we now have just 4 records. The last one is gone. So again, let me just run this so that you know the impact of that, you know the danger of that. So it says 4 rows affected. Okay, so now if we select from our person table, we now have no more records. Gone, all gone, because we used the delete from person without specifying the filter or the where clause, and that is very dangerous. If you have here hundreds of thousands of records and you have administrator access and you accidentally issue this command, then all your records are gone. You may have to restore that from your backup. Okay, so always specify the where clause when using the delete statement. Now let me just go back to our insert so that we have records to play with. So now if we select asterisk from person, we are back to 3 records. So again, you can delete the record from a table by specifying one or more filter criteria. So let's say I would like to delete from person where ID is greater than 6, for example, and first name equals Mark. Okay, so in this case we are interested in deleting this last record here, Mark Williams, because we are specifying greater than 6 for the ID, which these two qualifies, but we have extra filter here, the first name, which is Mark, so only this record qualified. So if we run this statement, this query, we now have one row affected. And if we select our table again, we just now have 2 records. So if let me just insert more records. So now we have another 3 records, and if we run this, we have 5 records now. So same thing with the retrieve and update. You can specify the wildcard also. So delete from person where ID is greater than 6, for example, and first name, let's say like Jane, and we put here the person sign, which means after the Jane, any character after the Jane is valid. So we should be expecting these 3 records to be deleted because they have all the ID which is greater than 6, and they have the first name of Jane. Okay, so let's try that. 3 rows affected. So if we select now from our person table, we only have 2 left. Okay, so that's about for the delete statement. So you can probably see the pattern now, that you can apply the same where clause for different operations. You can apply it from the delete, from the update, from the select. Yeah, for those 3, because insert does not require the filter. So only those read, update, and delete. You can apply the same where clause, the pattern. Okay. So there's one more thing that I would like to introduce here. As you might have noticed, that the ID, although we have 2 records only, we have the ID of 6 and 11. If let's say I want to reset the table, so I can use the truncate command, the truncate statement, truncate table statement. So basically this deletes all the records from a table and reset the ID, all the identity columns. Identity column. So in this case, if I truncate the table, then the table name, which is person, it will wipe out all the content and it will reset the value. Because now here, if we do an insert, let's say we insert this multiple times, it will, one more. So now we have 8 records. We have added 6, so we have 8 records. But you can see that the ID keeps on incrementing from the last digit, the last ID that's been inserted. So for this, just for testing purposes, if let's say you want to truncate the table so that you can start with a fresh set of data, then you can do this. And all gone. The table is gone. I mean, the table is there, but the records are gone and the identity has been reset. So if I would like to insert now here multiple times, 1, 2, 3, and we select our person table, we now have 9 records, which started from 1 again. Okay, so that's it for the truncate table. Another one is the drop table statement. This basically drops the table or remove the table from database. Okay, so drop table person. Again, these are all very dangerous commands. That's why if you are tasked to manage a database, you have to be very careful of these statements here, these commands here. Okay, so the drop table, it will wipe out the entire person table from our database here. So let's say we are done with all our testing and we don't need the person table anymore. So I'll just go and drop the table, and it says commands completed successfully. If we now select asterisk from person, it says invalid object name person, because it's no longer there. If we refresh this, the person table is gone. Okay, that's why it's always good to create a script. If you, let's say, if you create a table and you might be needing to create that particular table again in the future, it's always good to have a script, so that when you decide to recreate the table, all you have to do is run the script rather than going back to the tables again and specifying here the column names in your table. Okay, so that particular portion of the lecture will be introduced in the next section, where we're going to go through all this creation of tables here and creating the script. So you will learn that. Okay, so that's it for this topic, the CRUD operations, and I hope you learned something from here. And with that knowledge, you should be ready to move on to the next section. I'll see you there. Hello and welcome to section 3 of this course, Create Database and Tables. Let's just go through the topic that we are going to cover in this section. The first one is we're going to create our database. We will call that as CAD-DB database. And this will all be done using the SQL Server Management Studio. And once we have our database created, we are going to start creating the tables. So the first table that we're going to create is the lines table, which will store all the lines from the drawing, followed by the Mtext table, which will be using to store all our Mtext from our drawing, followed by the Polylines, which will store all the lightweight polylines in the drawing. And the next one is the blocks no attribute. This will store all the properties of the blocks that do not contain any attribute. And finally, we're going to create the table for the blocks with attribute. And this table will store all the blocks containing the attributes and also including their properties. So in the next video, we're going to start working on creating our CAD-DB database. I'll see you there. Our first task in this section is to create the database. So let's open up our SQL Server Management Studio. And we can either log in using the Windows authentication or the SQL Server authentication. So if you have specified the password during the installation, then you can type it in here using the SA account. But in our case, we'll just use the Windows authentication and click on connect. So now if we expand the databases here, we don't have any database so far yet. So there are two ways to create a new database. The first one is we can either use the SQL statement called create database. So let's say we do create database and then the database name, let's say CAD-DB. That is one way. And the other way is to use the wizard, like you right click on the database folder and click on new database. And now we are presented with a form where we can just specify our database name. And you might notice here that the path or the location of the database will be stored in this folder. So program files, Microsoft SQL Server, Express, and so on in the data subfolder. This is actually your installation folder of Microsoft SQL Server. And now we don't have the logical name here yet. So if we type in CAD-DB, now we have the CAD-DB database with the log file. So initially it is configured to have a 8 megabytes in size, and it will be auto growth by 64 MB to unlimited, to the maximum size that SQL Server Express can provide. So if we check the location here in our Windows Explorer, these are all the current databases there. We have just, these are the default or the built-in databases together with the SQL Server installation. We have the master and model and so on. So once we create our database by just clicking OK, then it will now create a CAD-DB database for us, and also the corresponding log file. So it has an MDF extension, and for the log file it has an LDF extension. So now if we look at our databases folder here, we have the CAD-DB database. And if we expand that and click on table, we don't have tables yet. So in the next video, we're going to start creating our tables, and we will start with the lines table. I'll see you there. All right, let us now start creating tables. In this video, we're going to create the lines table. So right click on the tables folder, click on new and select table. The first column that we're going to create is ID. And we will give this a big int data type. And we are going to uncheck this allow nulls value here, the checkbox, because this will be our primary key, which means that it doesn't allow a null value. So let's right click on this one here and set as primary key. And also I would like this column to make it as identity column, which means that it will auto increment every time we insert a record. The ID value will increment by 1, and it will start from 1. That will be the first record. Okay, so that's done. Next, we're going to create columns for the coordinates, for the start point X and Y and the end point X and Y also. So let's start with the start point X, and this one we are going to provide the data type of decimal with, let's give it as 8 decimal places. And also now we are going to create the start point Y. We'll also give it a decimal data type, and we are not going to allow null values for this column. And followed by the endpoint X, which is also be a decimal, and then endpoint Y, also a decimal. Next, we will create a layer column, and in this case we are going to make this as varchar 50, and we can allow nulls on this one, no problem. And next, let's create a color column. This one will also be a varchar 50, followed by the line type, which is also varchar 50. Then the length. For the length, let's give it a real data type. And next will be the audit columns, which are the created. This is the date created, so this will be a date time data type, followed by modified. This will be the date modified. If that particular record gets modified, then we will populate this column so that we know when it was modified. So this will also be a date time data type. The next one is the flag for the is deleted. We'll just put this as a bit 1 or 0, which means that if it's 1, then it is deleted. If it's 0, then it is active. The reason being I created this is we are just going to make a soft delete. We're not doing a hard delete, which means that deleting the entire record from the database. So we'll just mark this as 0 or 1. At least we still have all those objects just in case we wanted to undo the deletion process. Okay, followed by the deleted column, which is also a date time. So we can capture when it was deleted. You might even add deleted by so that you know who deleted it, but for simplicity purposes, this should be sufficient for our requirement. Okay, so now that we have this table, let us save this and let's call this as lines table. Okay, so I usually script this table into a script file. The reason for that is if we are going to modify the table structure, we don't have to go through this process again. All we have to do is modify the script and then run it. So let's do that. Right click here and let's refresh this tables folder. So now we have this lines table, and now we can right click and then script table as. We're going to create a new query window, and this is now our create table script. So you can see here, these are all our definitions. So what I was saying earlier, if you decided to, let's say, add more columns here, then you just have to edit this and provide the column names that you want, or if you want to modify or you want to remove some of the columns, it's up to you. At least now we have this script created. So let's save this file and let's put it into the projects folder as SQL script, and let's call this as how do you call that? Create lines table, or let's just call that as create table then underscore lines. Save it. Okay, so now we have our script here. We will be doing the same thing for the other tables that we're going to create. All right, so that is our lines table. In the next video, we're going to create the Mtext table. I'll see you there. Let's continue creating tables. In this video, we're going to create the Mtext table. So right click on the tables, click on new table, and now we can start creating the columns. Let's start with the ID, and this will also be a big int, and we are not going to allow null values. And we can set this column to be an identity column, which means that it will auto increment every time a new record is inserted, starting from 1, and it will just increment accordingly. And we will set this as our primary column. So now that we have the ID, we can create more columns, and let's start with the insertion point. So we'll just have here ins ptx. This will be a decimal value with 18 digits whole number and 8 digits decimal places, followed by the ins pty, also a decimal. Let's just copy this over, and now we can add more column like the layer, and this will just be a varchar 50. We can allow null values on this, no problem, followed by the color, also varchar 50. Next is the text style, varchar 50. followed by the height. This will be a real value, and width also a real value type, data type. Next will be the text string, the actual text string. Let's just give this a name of text, and this time we're going to make this as a varchar max, just to make sure that we can accommodate any length of text string in the drawing. Next, we are going to have a column for the attachment. This is the position where the text is located. So this will be an integer value. And next columns will be the audit columns. So let's start with the created. This is the date time. The modified, which is also a date time. And the flag is deleted. It's just a bit. And the final column is the deleted column, which is also a date time column. Okay, so this will be our Mtext table. Let us save it and give it a name, Mtext. Now we can refresh these tables here. We should have 2 tables already, and now we can script this to a file, and this will be our script. So now let's save this as the let me overwrite this existing one here. Save it. Yes. Alright, so now we have a Mtext script to create the Mtext table. Perfect. So that's it. If we select now our Mtext table, we now have all our columns here, and we'll soon be populating this table in the upcoming videos. Okay, I'll see you in the next video. The next table that we're going to create is Polylines table. So let's right click on the tables folder, new table. Let's start with the ID again. Let's change this to big integer. And let us change the settings for the identity specification again to yes, so that it will auto increment. And let's set this as the primary key. The next column that we're going to add is the layer column, and we'll just choose varchar 50 here, not null, and line type column, also varchar 50. This one we can allow null value, no problem, followed by the length. So this will be a real value. You can just leave it as null. And the next one is coordinates. Alright, so in this case we will capture the coordinates as a string. So let's select the varchar max. There are many ways to capture the coordinates. We can create a separate table and link it with the IDs for the coordinates as a foreign key to other table. However, I would like to just keep them all in one table, and we will just do a kind of separate those coordinates x and y between vertices. So let's just do this, varchar max, and this we cannot allow a null value, so there's no point having a polyline without coordinates. So the next one is we will add a column called is closed, because some polyline are closed and some are open, and we just set this as the bit. And then our audit column created, this will be date time, followed by modified. This will also be a date time, and also the is deleted flag. This will also be a bit, and followed by deleted. This will be a date time data type as well. And that's it for this Polylines table. Let's go ahead and save our table, and we call it as Polylines. There you go. So now if we refresh our table here, we should now see 3 tables. So select asterisk from Polylines. We now should have oops. Okay. Let's select the CAD-DB and execute it. Yeah, so this is now our table. We will populate this later on with all the polylines from the AutoCAD drawing. Alright, I'll see you in the next video. Okay, let's continue building our tables. So in this video, we're going to build the blocks no attribute table. So right click on the table, click on new and table. Let's start with ID again with the big int. We should not allow a null value, and let's change the identity here to yes, so that it will auto increment for us. And again, set as primary key. Next column is the insertion point. Let's just call that as insertion PT. And this time I would like to use the varchar 50 on this instead of having a separate x and y coordinate. This time I'll show you how to use a single data type, capture it as a string, and then we will just parse later on when we write the code in our C# module. So let's change this to does not allow null value, and the next one is block name, and this will be varchar 50. We can allow null value there, no problem. Followed by layer, varchar 50, rotation, this is important, and this one we will just use a real value. And now the audit column, so created, date time, modified, date time, the is deleted flag as a bit, and deleted date time. Okay, so let us save now our table, and we call this as blocks no attribute. Okay, again we have to script this table into a file just in case we need to do some modification later on. Click to a new query window, and this is now our create table script. So let's save this as create table, create blocks no attribute table. Save it. We might as well do for the Polylines also. I think I forgot to create a script for this one. Create table, and this will be our Polylines. Let's save this also. Create Polylines table. Okay, so now we have 4 tables. The next table that we're going to create is for the blocks with attributes. I'll see you in the next video. Alright, so let us now create our final table, and it is called blocks with attributes table. So right click on table here, new table, and let's have a primary key of ID, and this one will be a big integer, and change the identity specification to yes, and set as a primary key. And our next column will be the insertion point, again just same as the previous table, and this one we will also use the varchar 50, not null. And the next one is the block name. This will be a varchar 50 also, followed by the layer. This will be varchar 50 as well, and the rotation angle, so let's just call that as rotation. This will be a real data type. And the next one is the attributes. So this column will store all the attributes of a block, and in this case we have to change this to a varchar max, because we don't know how many attributes the blocks will contain. So at least we are safe if we use the max here rather than specify some numbers. And now we will create the audit column. So created, date time, modified, date time, the is deleted flag, which is a bit, and deleted date time. Okay, so again, the only difference between this blocks now attribute and this new table is the attributes column, where we will store all the attributes separated by a comma. I'll show you later on when we start coding in our C#. So let us save this table and call it as blocks with attributes. Alright, and of course we need to script this table just to have a script ready if in case we need to modify, or let's say add or delete some columns in the future. It's quite handy having this script ready for us. So let's call this, save this and call this as create blocks with attributes table. Alright, so we are done with all our tables. So now we should be ready developing our program in Visual Studio. So I'll see you there. Hello and welcome to section 4 of this course, loading data into database. In this section we will be loading the AutoCAD objects properties into our SQL Server Database. We will be starting with the line objects. If we look into our drawing, this will be a drawing that we'll be working on. So some of the line objects here are this staircase here. So you will see we will extract all the line properties, and then we will load into the SQL Server tables. And that will be followed by the Mtext. So all of these information here, all the labels for each of the rooms, will also be loaded into our Mtext table. And the third one is the lightweight polylines. So all of these perimeter wall here will be loaded with all the vertices, all the coordinates of the vertices, as well as some other properties like the length and line type and so on. Then it will be followed by the blocks, those blocks that do not contain attributes, like for example the toilet here, the sink, the bathtub. All of these blocks without attributes will also be loaded. And the last one are those blocks with attributes. Some of these blocks here, for example the bifold doors, they have all the doors specifications like the width, the height, and so on. So all of these will be loaded into our table in our SQL Server database. So each of these objects have their own corresponding table that we have already identified from the previous section. So those columns that we have identified will be populated accordingly with the properties from the objects that we are extracting from AutoCAD. Okay, I'll see you in the next video. Our first task is to load the line objects into database. So let's just have a quick overview of the process. So from our AutoCAD drawing, we are going to extract all the line objects like these staircases here, and also the deck and the foyer. So this will be our database table. We call it as lines table, and these are all the information that we need to load, like the coordinates, both the start point and end point for X and Y coordinates. And then we have the layer, the color, and the line type, and the length. We also populate the created date when it was loaded. Okay, so in the next video, we're going to start our project. I'll see you there. Okay, let us now create our project. So fire up your Visual Studio 2019 and click on Create a New Project. And make sure to select C# here in your language. And let us search for class library. And we will be using the class library.net framework. Click on Next. And I'll call this project as CAD DB. And the location is in the C projects folder. Choose the .NET Framework 4.7.2. Make sure you have it installed. If not, you can just download it from Microsoft website. And then create. Okay, so first thing that we need to do is to add the AutoCAD.NET API. So let's right click on references and click on add reference. So we'll have to browse those files, and you can find those files from your AutoCAD installation folder. So in my case, it's in the program files, Autodesk, AutoCAD 2021, and you can find it here. So we are going to add the AC Core MGD, ACDB MGD. So you have to press the Control key from your keyboard. And then the third one is the AC MGD. This one here. So AC MGD, AC Core MGD, and ACDB MGD. Okay, click on OK. Next, we have to set the copy local property to false. This is just to make sure that when we compile the code, it will not add all these libraries that we have added. I mean, the DLLs will not be included in the compilation. Only our CADDB.dll project. Okay, so now that we have referenced all these .NET APIs, we can include them in our using statements here. So the first one is using Autodesk.AutoCAD.application services. The next is the database services. And the third one is the the editor input. Is just to provide some message to the user through the command prompt. And let's just do some cleanup here. We don't need the collections generic, we don't need the link, we don't need the text, we don't need the threading task. So let's just get rid of those, and let's add the system.data. You might notice it here, it's already added in the reference by default. So all we have to do is provide here the namespace system.data, and the other one is system.data.sql client. Okay, and that's all we need. Alright, so this is basically our project now. In the next video, we will continue building on this project, and we will start creating classes for each of the component or the module that we will be adding into our project. I'll see you in the next video. Okay, welcome back. Before we start coding, we need to establish or create a connection string first, which means that we will use that connection string to connect from AutoCAD API to the SQL Server Database. So to do that, we will need a file, a settings file, where we can store the connection string. So we have to right click on our project and add a new item here and select on the settings file. And this will be our settings. So let's give this a name. Let's just call this as constr, like a connection string. And the data type is a string, and the scope will be application. And the value here is the connection string, the actual connection string. If you are not familiar with creating a connection, excuse me, creating a connection string to the database, there is a website called connectionstrings.com. You can see this one here, connectionstrings.com, and you can select whatever database you would like to connect to. In our case, we will choose the SQL Server, and then we will choose the Microsoft SQL Client data provider for SQL Server, and choose your version. In this case, we choose the SQL Server 2019, and we will be using the trusted connection here. This is very simple and straightforward connection. So depending on the installation of your SQL Server, if you have chosen Windows and the SQL, how do you say that, the ID and password, where you have to specify both the ID and password, you can either choose this or you can choose the trusted connection. So in our case, we will just use the trusted connection, and then copy that over and paste it here. So all we need to do here is replace the server with our actual database server. So in our case, if you go to connect database, and this will be your server name. So just copy that over and replace this my server address here. And then the database, which is in our case is CADDB. So just replace this my database with CADDB. This is the one that we have created earlier. And trusted connection is true, which means that whenever you are log on to Windows, it will just get that credential, and you should be able to connect right away. So we have a name. We will use this to connect to our SQL Server. And let's save this. Now we can close this file. All right, so that is now our connection string. And in the next video, we're going to create a class, a dbutil class, and we can put our code in there. So we will call that method anywhere in our code. anywhere in our code. Okay, so I'll see you there. Let us now create the dbutil class. So from our project, right click and add class. We will call this as dbutil. And in this class, let's make it public first. In this class, we will be adding the get connection method. This will be the location where our connection string will be created. But before we do that, we need to add the using statement for the autodesk.autocad.runtime. We will use this also for calling the main form, the one that we'll be adding next, so that it will be our entry point where the user can interact with the form. And another using statement that we need to add here is the system.data.sql client. And the rest we don't need, so we can just get rid of that. And we will make this as static class so that we don't need to instantiate it. We can just use it right away. So the first method that we're going to create is public static SQL connection. So we will be basically returning the SQL connection, and we will call this method as get connection. So let's declare a string, connection string variable, and this variable we will get the settings, the connection string from our settings file. So settings 1 dot default dot constr. So now we have the connection string that we have specified here. Next, we will create a connection object, SQL connection, and let's just call that as con equals new SQL connection, and we will pass in the connection string constr. There you go. And we will return the connection. Okay, we will let the calling method to open or close the connection. The objective of this method is just to provide you the connection. That's all. And this is it. So in the next video, we are going to start coding the load lines method. I'll see you there. Okay, now that we have the get connection method, we can now start creating our load lines method. So let's go back to our class 1. This is the initial class that's been created. Let's just rename this to db load util. Okay, so now we have our db load util class. This is where we can start now creating our method. So the first method that we're going to create is the load line. So this will be load all the line objects into database. So the method would be returning a string value, and we will call that as load lines. The string that we are going to return is just a message whether the execution of this method was successful or not. So in this case, let's create a variable called result equals just an empty string. And now we can call the SQL connection. We can now create a SQL connection. Oops, this is supposed to be SQL client. So now we can call the SQL connection. Let's just give it a name with con, and that will be coming from our db util that get connection. Okay, so next let's create a try catch block. So in here we will catch if there is an exception. Let's just provide there an EX, and we just say that, just store the error message into the result variable. And let's add also a finally block here, which means that this will handle the connection to our database. So let's just put here, if the con state equals connection state dot open, then we will have to close it. We don't leave it open, and that's it. So every time the connection is open, it will close it right away every time this method finished running. And then at the end here, we will just return the result. Okay. All right, so now that we handle the try catch finally code block, we can start coding here. So the first thing that we need to do is to get hold of the document and the editor object. So document, let's give it a name of doc. That will be the application that document manager that MDI active document. If you are not familiar with all these, I encourage you to check my other courses that explains to you all these API objects that we need in our coding to manipulate AutoCAD .NET API objects. So we will be using also the editor, and let's just give that a name of ed and then doc.editor. Now we can start creating a transaction. So using transaction, let's just call that as trans equals doc.transaction manager that start transaction. Okay, so we need a filter so that we can only filter all those line objects. To do that, we have to create a typed value, and it is an array, and we just give that a name of TV equals new typed value, and we will have it one index, which means that it should hold one value. So TV.setValue equals to new typed value, and we will start with the DXF code start, and the parameter is line, and that will be stored in our type value array here. So we need to cast the DXF start to int. So DXF code dot start, and the object value will be line, and that will be the index of 0. That's the only filter criterion that we have. Now we can create a selection filter. So selection filter, and let's just call that as filter equals new selection filter, and we will pass in the typed value. All right. Next, we are going to execute that filter using the select all from the editor object. So to do that, we will create a prompt selection result. let's just call that as SS prompt, and that will be coming from the editor object that select all, and then we will pass in our filter, our typed value, or the selection set filter, which is the filter here. Okay, next we just have to validate if, let's say, check if there is object selected. So to do that, if this SS prompt that status equals prompt status dot OK, which means that there are objects selected, then we will do our coding here. Otherwise, if there is nothing there, so we'll just kind of message the user like editor object dot write message, no object selected. Oops, no object selected. Okay, so now let us code the portion here where we are going to capture all the line objects property and then store it in the database. So first off, we need to create some variables that will hold those properties. So let's start with the start point and end point for both the x and y coordinates. So double start point x equals 0, 0, and start point y equals 0, 0, end point x equals 0, 0, and endpoint y equals 0, 0. You might notice that I just created them in a single line since they have all the same data type, just to save us space. And a few more properties that we need to capture, so we will store them in layer, line type, and color. So let's declare a string variable called layer equals an empty string, L type also an empty string, and color an empty string as well. Next, the property that we need to capture is the length property. So let's just create another double variable and we call that as len. That will store the length of the line. And now we can create our line object. So line, and let's just call that a line. That will be a new line. And now we can basically gather all the values that's been gathered or collected by this SS prompt and store that into a selection set. So selection set, we call that SS equals SS prompt dot value. So now we have all the values that's been collected into our selection set here. So next we need to create a SQL query as a string. So we will do that by composing the insert statement. So string SQL equals, we'll put here an @ sign, and that will be enclosed in this string code here. So we are going to insert into dbo.lines. This is our table. So the syntax to insert is to specify all the column names that we would like to insert values into. So let's start with the start point x and followed by start point y, end point x, end point y, then layer, color, line type, the length, and the created. So these are the columns that we are going to insert values of. And now we can specify the values. So insert into line objects, the line table, lines table, that will be followed by at start point X, at start point Y, end point X, end point Y, layer, color, line type, length, followed by created. There you go. Oops, this should be all right. So this will be our insert statement. So if we check the lines table, these are the columns that we are inserting our records into. So we have here the start point X and Y, end point X and Y. We have the layer, we have the color, we have the line type, length, and the audit columns, which are the created, modified, is deleted, and deleted columns. Okay, so you can also see it here. This is the column list of columns for the lines design table. So now we can go ahead and continue our code. Now that we have this SQL statement, we can now open the connection. So con.open. Next, we have to loop through the selection set that we have here and then process one object at a time. And then we will do the insert for each of the loop iteration. So loop through the selection set and insert into database one line object at a time. So to do that, we need a for each loop, and then the selected object from SOBJ, let's call that as SOBJ in the selection set, which is the SS here. We are going to create a line out of the SOBJ object here. So to do that, we have already initialized here the line object. So line will be equals to the transaction get object, and then we will need the SOBJ ID, object ID, then open mode for read. Then we will cast this as a line object. Okay, now that we have the line object, we can now extract all the properties of this line. Starting from the start point X, so this will be the line that start point, then X, followed by start point Y, which is the line that start point dot Y. And now we can get the endpoint, line dot endpoint dot X, and of course the endpoint Y, which is the line dot endpoint dot y. Next, we need to get the layer, so let's get the layer by just typing in the line dot layer, followed by the line type equals line dot line type, and the color, which is the line dot color, dot toString, and finally the length, so len equals line dot length. There you go. So now that we have all these values here, all we have to do is create a command, a SQL command, so that we can execute that command to insert all these values into the columns. So to do that, we have to create SQL command, and let's just call this a CMD equals new SQL command, SQL, that will be the string command text, followed by the connection. So we have here the connection. Okay, now we will add the parameters. So cmd dot parameters that add with value, and we will start with the start point x, and the value of that will be the start point x we have here. Oops. All right. Next, we can just copy this over, as we will be creating at least 8 or 9 parameters. So when we are doing this copy and paste, make sure that you will update accordingly to avoid some errors. So the next one is the start point y, and this will be start point y, followed by the endpoint x, and this has to be the endpoint x, and endpoint y, this has to be the endpoint y, endpoint y, capital Y. Next is the layer, and we will have here the layer variable, followed by the color. Basically, we are replacing all of these parameters here with this actual value. So this will be the color, and this is for the line type, and this will be the L type, and the next one is the length. This will be the len variable, and finally we have here the created, and this one we don't have a variable for this, but all we need to do is use the date time now object, and that's it. So now that we have supplied all the parameters required by our query here, we can now execute our command. So cmd dot execute non-query, so this will execute our command, and that should be the command that we have to use, and that should execute it properly, unless we miss something or unless we type in incorrectly. But nevertheless, this will be the code completion. So all we have to do now is return the result, or I mean assign a value to the result variable, saying that it's done and completed successfully. So this message will handle both the if statement here, whether there is a line to be processed or not. Nonetheless, our messaging is clear enough for the user to know what happened. if in case there are some issues that we encountered in this code block here, it should be able to flow through the catch block, and we will intercept the message, and then we will return the result as well. So that's it for our load lines method. In the next video, we are going to code the user interface, and we can test out this first method here. Okay, I'll see you there. So now that we have the load lines method, we can create our user interface, and we can call this method so we can test it out. So the first thing that we have to do is add a form in our project. Right click on our project here and click on add. We will select the add forms here. Let's just call this as main or main form. Okay, so let's create a group box. This just we can group all the related functionalities together. And we can add one button control. So let's give this a name and call it as BTN load lines. And let's update the text to load lines to database or DB. Let's just give it a forecolor of light green. Oops. Control Z to undo. I mean the back color, not the forecolor. Okay, so let's change that to the size of 150 and 50 height, and let's change the font to bold. Okay, and let's just rename this, let's just update the text of the group box here to create. So we will have 3 more of these group box: create, update or retrieve, update, and delete. In the meantime, we just have to build the functionality one method at a time. So now we have these load lines to DB method. Now if we double click on this, we can now create an instance of our DB util and the DB load util. So if we go back to our code here, DB load util, and let's just call that as DB load equals new DB load util. Then let's just create a result variable as a string, and we call the method load lines. Then going back to our form, we need a way to provide the user a message, the results of our database process. So let's just provide a label control here, and we will call this as LBL info. Let's just provide a name, a text for that. saying message here. Okay, so now whatever the result we got from calling this method, I mean the load lines method, we're going to display in the label control equals result, and that's it. So before we can test our first method, we need to create an entry point from that we can call from our AutoCAD command line. So let's do that in the dbutil class. Let's create a method here to run our program, our plugin. So let's do a static method here, static void. Let's just give this a name as dbrun, and then we're going to instantiate the form. So main as a main new main. So this is our main form. We are basically instantiating a form, and then we will provide here a show dialog. We'll make a show dialog so that it will always be on the front, and we can avoid the user from creating or running the db run and having a multiple windows showing up. So in this show dialog, there's just one form that's active. Okay, so before we can run this, we need to provide a method signature. So command method. Let's also just give this a name as dbrun, and this is the command that will be available in AutoCAD command window. You can rename this as however you like, but let's just give it the same name as the method name. So that's it. Let's save our project, and in the next video we're going to test our first method. I'll see you there. Welcome back. So now we are ready to test our first method. So let us build our project. Okay, there is a mismatch saying that the processor architecture, so let's fix that. Project, build configuration manager, and let's create a new and x64 and close it and do another build. Okay, so one succeeded. Let's also do a debug here, which means that when we run our code, we will open up the AutoCAD application. So go to the debug and start external program, browse for the AutoCAD exe file, AutoCAD.exe, browse for the location of the file. So in my case, it's in the program files, Autodesk, AutoCAD 2021, and select the AutoCAD.exe. Okay, good. Save it. Now if we start, click on start here. Let us select these blocks and tables. Alright, so now we can type in the netload command, and we can look into the projects folder. We have here the CAD DB bin, and it's in the x64 debug folder. Click on always load. So now we should have the db run command. Let's try that. Db run. There you go. So before we click on this button here, let's just examine first the database, the table that we are going to populate. So we have here the lines table, and we have no records so far. So the expectation is once we click this button here, we should have all the lines from this drawing. These are all the example of the lines, the staircase, and some of these lines here in the foyer. So let's run it. Now we have here done, completed successfully. So now if we check our database and we execute the select statement, perfect. Now we have this ID, which is auto incremented up to 76 rows. So we have 76 records, which means that this drawing has 76 line objects. Okay, and we have all the starting point X and Y coordinates, and we also have the endpoints. We have the layer, we have the color, we have the line type, we have the length, and the date created. So all of our other audit columns are empty or null. So this will be populated later on when we go to the other crude operations like update and delete. So that's it. So now we have successfully loaded our line. So just to verify that we have 76 lines in AutoCAD, let me just close this and let's set q lines is get x 0.line list lines. Yeah, 76 pound. There you go. Awesome. Okay, so I'll see you in the next video. The next object type that we're going to load into database is the Mtext object. So let me just walk you through the process again. So from our AutoCAD drawing, all of these Mtext that we have here, like living room, laundry, master bedroom, we will extract most of the properties that we need into our Mtext table. So the properties will be as follows, like the insertion point X and Y coordinates, layer, color, text style, height, width, text attachment, and of course the created date when we inserted the records. Okay, so in the next video, we're going to start our coding for Mtext loading into database. I'll see you there. Let us continue building our project. In this video, we're going to create the method to load the Mtext. So what we can do is just copy this over because they have the same structure, and we're just going to change some of the properties here as well as the SQL insert statement and the parameters. But other than that, all the try catch finally blocks are all the same, so we can just copy this over. Let me just copy this including the comment, and we'll just replace it or modify it later on. Control C, Control V. So let's call this as load Mtext. Okay, and the comment here will basically load all the Mtext objects into database. So we will keep this document and editor objects. We'll keep the transaction. So we have to change this line because now we are filtering all the Mtext instead of line. Okay, so we have the validation check here. Next, we are going to be needing the insertion point. So instead of start point, we just put here ins.ptx and ins.pty, and that's it. We don't need the endpoint x and y. We will need the layer. We don't need the line type, but we will be needing the text style. So let's just replace this with the text style, and we will also be needing the color. Next, we don't need the length, but we are going to need the height, so we'll just replace that with height, and also the width. Let's also initialize that to 0, and we will also need the attachment, so that is an integer data type, and let's just call that as attachment. So now instead of line, we are going to be using the mtext, and let's call that as mtx, and this will be new mtext. So we'll keep the selection set, but also we need a variable to store the text string. So we will just call that as string tx and initialize it to an empty string. Next, we are going to update the insert statement. So instead of lines, we are going to insert into the mtext table, and we just have to replace this with all the columns, like the insertion ptx and ins pty, followed by the layer, the color, then the text style, and followed by the height, width, and the actual text string, and then the attachment, and of course the created. So all of these columns, these are all the ones that we have created in the mtext definition, the table definition or table schema. Okay, all of this here. So now we have all the columns specified. We just have to replace these parameters here. So instead of start point x, it should be ins ptx and ins pty. No more the endpoint x and y. We have the layer, we have the color, we have the text style, followed by the height, followed by the width, followed by the text, and the attachment point, and finally the created column. Okay, so we're done with that. We will open the connection to the database and loop through the selection set and insert into the database one mtext object at a time. Okay, so instead of line here, we have to replace that with the mtx here, and this will be the mtext data object. So now we have here the ins ptx. This will be the mtx dot location instead of start point. That is the location dot x. Okay, and also the ins pty, that will be the mtx dot location dot y. Okay, and we'll get rid of the endpoint x and y. We have the layer, but we need to replace this with the Mtext. We have the color, which is mtx.color, and we have the text style, which is the mtx.text style name. And now we have the width, or the height. Let's start with the height, which is equal to mtx.text height. Then the width equals mtx.width. And finally the attachment. So we have the attachment equals, since this is an integer value, so we have to convert it to an integer 32. So we use the convert that to int 32 mtx.attachment. Okay, so now we have all the values ready. All we need to do now is replace these parameters with the correct parameter names here. So instead of start point x, this will be insptx. Instead of start point y, this will be the inspty. And we don't need this x and y. We have the color, we have the layer, we have the color. We will be needing the text style, and this will be the text style variable, and followed by the height. This will be the height. Let's just copy this 2 more times. So we need to have the width. This will be the width, and the attachment, the text. Let's capture the text first. That is the text string, and that is the tx. And let's copy one more time for the attachment, and this will be the attachment. Created, same thing. That would be datetime.now, and then we execute the query, and that's it. All the rest of the code remains the same. So basically what we have replaced is from this code block here up to the parameters, and that will be our load mtext method. So in the next video we're going to test out our method. I'll see you there. Okay, now that we have the load mtext method, we can now call this from the user interface. So let's go to our main form, and we're going to create a button here to call the load mtext method. Let's just copy this over and paste it here, and let's change the text to load mtext to db, and let's give this a name as btn load mtext. btn load mtext. Okay, now let's double click on this one to bring us to the code. So what we can do is just do the same thing here. Just copy this over, and instead of calling the load lines, we're going to call the load mtext, and that's it. So let us save our project, and now we can test the code. So let's start. Select this blocks and tables drawing. Okay, so net load. Let's find our project. It's in the projects folder, bin x64, and this will be our CADDB DLL. Okay, so if we type in the DB run, we now have the load Mtext button here. So again, the expectation is once we click this button, the Mtext table will be populated. So far it is empty. Yeah, there's nothing in here. Now let's click on this button. Done, completed successfully. So let's check our SQL Server. Perfect. Now we have all the data in our Mtext table. We have the insertion point X and Y. We have the layer, the color, the text style, the height, the width. But we don't have the text here. So it looks like we have issue on the code. Let's fix that. If we examine our code here, it looks like we have missed adding the text value, the text string. So let us stop our project, and let us add the tx, which is equals to the mtx.contents. This is the text string. Okay, so before we run this again, let's just clear up the mtext table. We can do two ways here. Either we delete from mtext, which means that we are deleting everything, all the records, or we can do the truncate so that we can start fresh, so starting from 1 again. So truncate table mtext. When we delete, it will just delete the record, but it will keep the identity sequence number. So the next time will be 18. But truncate means clearing the table totally, which means that we will be starting from 1 again. So let's do the truncate table here. Now if we select, we have a clear table, no records so far. So let us run our code one more time. Okay, so net load, this is our API. Click on always load, db run, and now let us load mtext to db one more time. Done, completed successfully. If we go to our SQL Server Management Studio and click on the select, now we have all the text here. Okay, and again it starts from identity column 1 to 17. Alright, so that's it for this video. I'll see you in the next one. Hello and welcome back. Our next task is to load the lightweight polylines into our database. So our process is the same as the Mtext and lines. So from our AutoCAD drawing, we are going to filter all the lightweight polylines, which mainly are these objects here, the walls. And the properties that we're going to extract will be loaded into our Polylines table here. So these are the properties that we're going to extract. We have the layer, we have the line type and the length, and also the coordinates, the concatenated X and Y values for all the vertices of our lightweight polylines. And we will also capture whether the polyline is closed or not. So it will be either 1 or 0 here. If it's closed, it's 1. If it's 0, then it is an open polyline. And of course, we are going to capture the created date when the record was inserted. So in the next video, we're going to start developing our method to load the lightweight polylines into database. I'll see you there. Welcome back. In this video, we're going to create the load polylines method. So again, we are just going to copy the earlier method that we have created, the load lines. We will just modify some of the code here, but the structure is the same. So just to save us time, copy that over and paste it here. And let's just change the method name here to, let's just call this as load polylines, and this will be load all the polyline objects into database. So we will keep everything here, and we have to change this string here. Instead of line, that will be LW for lightweight polyline. And next, we're just going to update some of the information here. We don't need a start point X and Y as well as the endpoints. We need the layer, we need the line type. Let's get rid of the color, and we need the coordinates. So in this case, we are going to just store the coordinates as a string, and we will need also the length of the polyline, so that's fine. And now instead of line, we're going to use the polyline here. And let's just call this as p-line, as new polyline. Selection set is still needed, but we have to add the is closed property. So that is a boolean, and let's call that as is closed equals false. Let's initialize it to false. And now we have to update the insert statement. So in this statement here, instead of lines, we're going to insert it in a plines table, and we just have to update these column names here. So what we have is the layer, we have the line type, we have the length, and also we need the coordinates, and the last one is the is closed column, and finally the created. So the values will be layer followed by line type followed by length and coordinates, and finally the is closed. Okay, so now we have a match between the column names and the values that we are going to pass on. So connection.open still remains there, and let's just update this to polyline, one polyline object at a time. So in this case, we will be using the p-line and cast it to polyline. And we don't need all these coordinates, the start point and end points, I mean. And we do need the layer, we need the line type, we need the length, we don't need the color, we need the length, and also the is closed. So is closed would be p-line that closed. So this will give us the value whether it's closed or not. It's a property, so we don't need the parentheses there. Okay, so now what we need is to get the p-line coordinates. So to do that, we'll have to develop a separate method to extract the polyline. So let us create a method called get polyline coordinates, and then we will call it from here. So let's just create the method first. However, I would like to create this in a separate class because we will be using this method more than once. So instead of creating it in this db load util, we might as well create a separate class to store all the common functionalities. So let's right click on this and add a new class, and let's call this as common util. Okay, and we have to include all the using statements for the AutoCAD APIs, application services, using Autodesk.AutoCAD database services, using Autodesk.AutoCAD.geometry. Okay, now we can make this as public static so that we can use the methods right away. We don't have to create an instance of this class. So the method that we're going to create is get polyline coordinates method. So let's just type in here the description of the method. Get all the vertices of the polyline and return it to the calling method in comma separated value format. Okay, so let's create our method now. Public static string. So the return value will be a string, and the method name is get polyline coordinates, and we will be passing here a polyline object. Okay, so what do we have to do to extract all the coordinates from polyline? Let's just create a variable. We call that as vCount, and we will get the number of vertices of the polyline that's being passed in this method. And then let's create a point to the coord, and we call that as coord. And another variable here, we'll call that as coords for coordinates, and just initialize it to an empty string. And we need a variable I, an integer, and then we can loop through the number of vertices count, and then we will extract all the coordinates from each of the vertex. So for I equals 0, I is less than or equal to vCount minus 1, then I plus plus. So the coord will be pl.getPointAt. This will be the built-in method to get the vertex of the polyline. So now that we have the coord here, we can now add into our coords variable. So coords would be plus equals coord 0, that is the x coordinate, to string. We'll be using the to string because we initialize it as a string here, plus we are going to concatenate with a comma, and coord 1, this will be the index number 2 basically, and this is the y coordinate, that to string. And let's just do a quick validation here. If I is less than the v count, the vector count minus 1, let's make it parentheses there, then coords plus equals comma. So basically what we're doing here is we are making sure that this is not the last vertex. So we are adding comma for as long as we are getting some points or vertices. Otherwise, if it's the last coordinate, then if it's the last vertex, then we don't need to add a comma there. So we have all the coords in this variable. We can now return that value. Return coords. All right? And that's it for our get polyline coordinates method. So now that we have this, we can call it from our load polylines method here. Okay, so let's continue building this method here. So now we can call that methods equals coords would be equals to common util dot get polyline coordinates, and we will pass in the pline object. Okay, so next we have here the SQL command. Let's get rid of the start point and end points. So we have the layer, we have the line type, we have the length. Next we need the coordinates. So we have the coordinates there, and the value would be the coords. Okay, and the next one is the is closed property, and we are passing here the is closed value. And again we have the created, and we execute the query, and that's it. So now we have a complete method to load the polylines into database. Alright, let's save our project, and in the next video we're going to test our code. I'll see you there. Okay, so let us now create a button in our user interface to test out the load polylines method. So let's just copy this button here and paste it, and let's update the text here. Load polylines to DB, and let's give this a name as btn load polylines. Okay, so if we double click here, it will give us the code behind. Next, let's just copy this over, and instead of calling the load mtext, we'll be calling the load polylines. There you go. And we will display the results. Alright, so let's save this project and let's run our code. Let's open the blocks and tables imperial drawing. And now let us load our plugin. CADDB.dll. So db run. There you go. Now we have our load polylines to db. So again, once we click this, our table will be populated, the plines table. So if we select from our plines table, there is no records in here. So once we click this, it should populate that table. So let's click on load polylines. Done, completed successfully. Let us check our database now. Nice. So we have here 9 polylines, and these are all the layers, the line types, the length, and if you look at these coordinates here, these are all comma separated values, which comprise of the x and y for each of the vertex. Okay, so later on when we retrieve this, we will just parse this accordingly into 2 so that we can get both the x and y for each of the vertex. And also we have here the is closed, which captures some of those that are closed and some are not. And this is the created date. Alright, so that's about it for the load polylines, and I'll see you in the next video. The next object type that we're going to load into database are those blocks that have no attribute. So from AutoCAD drawing, we have quite a number of blocks here that do not contain any attribute, like the toilet, the sink, the bathtub, and so much more. And we are going to extract those properties, and we are going to load into blocks no attribute table. The properties that we're going to extract are those block name, layer, rotation, and the insertion point. So you might notice here that the insertion point is separated by a comma for both the x and y coordinate. Unlike for the previous tables like the Mtext and lines, we have separated them into x and y columns. So this is just another way of storing the insertion point, for example. So you can just combine them in one single column. Okay, so in the next video, we're going to create the method to load the blocks into a database. I'll see you there. Okay, let us now develop the method to load the blocks that has no attributes into database. Let's just go back to our load lines method, and we'll just copy this again and then paste it here. So we'll just rename this to load blocks no attribute. Okay, and the comment here, load all the blocks no attribute into database. Yeah. Okay, so we all need this line of code here, including the transaction, but we have to change this filter here. Instead of line, we are going to put an insert, which means that we are filtering all the blocks. And we'll keep all this validation. And now we need the insertion point of the block. So instead of start PTX, we will use the ins PTX and ins PTY. We don't need the endpoint X and Y. We need the layer. We also need the block name. We don't need the length, but we need the rotation angle. So let's just call that as rotation. And instead of line here, we're going to use the block reference. So let's just call that as BLK. And also we need the insertion point. So string ins PT. Let's just initialize it to an empty string. So yeah. Now we have to update our SQL query here. So instead of inserting it to a lines table, it will be inserted to blocks no attribute table, the one that we have created earlier. So there is no start point and end point, but we have the insertion point, insertion PT. Okay, and we have the block name, the layer. We don't need the color, we don't need the line type, we don't need the length, and we need the rotation angle. Okay, next, for our values, we have to specify here the insertion point, followed by block name, layer, then we don't need the line type and length, but we need the rotation. Okay, so the column names and the values matched, so we are good with this SQL statement. So if we check from our table here, select asterisk from blocks no attribute, these are all the columns that we are basically adding into our SQL statement. So we have the insertion point, we have the block name, we have the layer, we have the rotation, and the created column. And in the values, we are going to pass in the insertion point parameter, block name, layer, rotation, and created. Okay. Okay, so we need this connection open, and then we can loop through the selection set and insert into database one block object at a time. Okay, so we don't need a line, but we will need the block reference. So that would be converted as block reference. Okay, so before we extract all the properties, let's just do a quick validation here to make sure that we are only extracting those blocks, that those are the valid blocks and not those anonymous blocks. So to do that, we have to check the block attribute attribute collection that count, since we are only extracting those blocks without attributes. So we are going to check whether they have a attribute collection count which is more than 0. So we will only accept those that are 0. And also the block that name that contains asterisk, but this condition we are going to negate this, which means that we are going to check that the blocks that we are extracting does not contain an asterisk in the block name, which means that it is not an anonymous block. And then we can start extracting the properties. So let's just move this inside the parentheses here. Okay, so the first property is the insertion point X, which is the BLK that is start point, not start point, but position dot x, and the insertion point y will be the blk dot position dot y coordinate. We don't need the x and y. And now we can compose the insertion point. So we have here declared the insertion point variable. So now we can inst.pt equals the inst.pt x to string plus, we just concatenate this with a comma for the x and y. So inst.pt y dot to string. And next we will need the block name. So the blk name, which we initialize here as empty string, will be the block name. Okay, followed by the layer, which is the blk.layer. We don't need the line type, color, and length, but we need a rotation. So the rotation, the value of the rotation here will be the blk.rotation. That's the rotation angle. Okay, so now that we have all the properties, all we need to do is replace all the parameters that we have specified in this insert statement here. So we'll have to replace this insertion point with the inst.pt. There you go. We don't need the start and end points. We need the, let's just copy this over. We need the block name, which is the blk name. Okay, we need the layer. We don't need the color, we don't need the line type, we don't need the length, but we need the rotation, and this will be the rotation angle. All right, and that's it. So now we have a complete code to load the blocks without attributes into the database. Okay, so in the next video we're going to create the user interface for this, and we are going to test this code. I'll see you there. Okay, let's keep going and let's test our method load blocks no attribute. So we'll go back to the main form and let's just copy one of these, and let's call that as load blocks no attribute to DB, and let's change the name to btn load blocks no attr. Should be good. And let's double click on this so we can just copy this code line here, and instead of load polylines we're going to call the load blocks no attribute. Okay, all right, so now we can run our project. Click on start. Let us select these blocks and tables. All right, so let us load our plugin. Okay, so db run. All right, so now we have here our method or button to load the blocks without attributes to database. So let's just examine the table first. So if we select our table, we don't have any records so far. So now let's click the button. Done. Completed successfully. Let's go back and select one more time. There you go. So let's examine the data that's been inserted. So for our insertion point, we have here the x and y separated by a comma, and we have all the block names that do not contain any attribute. We have the sink, toilet, bathtub, and lighting fixtures and column. These are all the layers, and we have the rotation angle and the date created. Alright, so that's about it for this video. In the next video, we're going to develop the method to load the blocks with attributes into database. I'll see you there. The final object type that we're going to load into database are those blocks with attributes. So from our AutoCAD drawing here, there are quite a number of blocks that have attributes here. For example, the French doors, the bifold doors, and some other blocks. And we are going to populate our table that is called blocks with attributes with the following properties that we are going to extract. We have here the insertion point, the block name, the layer, and the rotation. And we have a new column called attributes. The way we're going to extract the attributes will be, they will have a comma separated value format where we will capture the name of the attribute and the value, then comma followed by the next set of attributes. And of course, we have to capture also the created date when the record was inserted. So in the next video, we're going to develop our method. I'll see you there. Our next task is to load the blocks with attributes into database. So let's create a new method for that. But since we already have these existing methods that we have created from the previous video, we can just copy this method as they are very similar. We'll just be adding some code here for the attributes. So let's copy this over and paste it at the bottom. So let's change the comment here with attributes. And this one will be load blocks with attributes. Okay, so let's examine the code line by line. We are good up to here. It's just the same. So for the insertion point, we have the X and Y, we have the block name, layer, rotation. We also have the block reference. We have the insertion point. So we need to add the attributes. This will store the concatenated value of the attributes. Next, we have the SQL statement here. So instead of blocks no attribute, this will be blocks with attributes. And we have the insertion point, we have the block name, we have the layer, rotation, but we will be needing the attributes column here. So in our values, all we have to do is add the attributes parameter, and that should be good. So next, we have here the looping through the selection set, and for the validation of the blocks with attribute, instead of equals to 0, we have to change it to greater than. We'll make sure that we are extracting those blocks with an attribute collection count of greater than 0. And of course, we are ignoring those that are anonymous blocks. So we have here the insertion point, X and Y. So we compose our insertion point based on these values. We have the block name, we have the layer, we have the rotation. So the next thing that we should do now is to extract the attributes. So we have here the collection of attributes. What we need to do is to loop through the block attributes. So we will be needing a for each loop object ID, and let's call that as @ref_id, attribute reference ID, in block.attribute collection. So let's generate an object from this @ref ID. So let's just initially set it to a DB object, and let's call that as obj trans.get object. That will be the @ref ID, and open mode for read. Okay, so now we can cast it to the attribute reference. So attribute reference, let's call that as @ref equals obj as attribute reference. Okay, next we'll just do a quick check. If the @ref is not equal to null, means that it has a value, we are going to concatenate those attribute tags and values. So we will store that into our attributes variable here. That will be plus equals to @ref tag plus the equal sign plus the @ref that text string. This is the value plus the comma, because we are separating them by a comma. You can use a pipe symbol or any symbol you like, but for this tutorial we will be using just a comma. Okay, so that's it. So now we have extracted all the attributes and store it in our attributes string. So we need to clean up these attributes because the last character has a comma. So all we have to do is remove the last character. So attributes will be equal to attributes.substring, and we start from 0, the first character, followed by attributes.length minus 1. Basically we are excluding the last character, which is a comma here. Okay, so now we have a command parameters here, and we are just missing these attributes. So let's copy this over and change this to attributes and replace the rotation with the attributes. Okay, and now we have to execute the command, and when it's done we have to make sure that we clear the value of the attributes, because we are looping to the next attribute again, and we will be concatenating the attributes values and the tag and the text string. So we have to make sure that for every pass, for every iteration, we have to clear the value. Otherwise, this will keep on adding, and it's not the correct information that we are gathering then. So this should be the complete code for our method. In the next video, we're going to test this out. I'll see you there. Let us now test this method. So let's go to our main class and let's copy one of these buttons here. So we'll rename this to load blocks with attributes to DB, and for the name we'll call that as btn load blocks with attributes. Okay, let's double click this and we can just copy this code here and replace this method call to load blocks with attributes. There you go. Save and click on start. Okay, let us load our plugin. So So let us run our plugin, db run. Okay, let's just examine our table. Select asterisk from blocks with attributes. Yep, we have no records. And now if we click this button here, done, completed successfully. Run it again. There you go. So we have the insertion point, we have the block name, we have the layer, the rotation angle, and the attributes. So if you look at the attributes here, they are concatenated, separated by comma. So we have the tag, we have the value, tag, value, tag, value. And some of the attributes does not have a value, does not have a text string. Okay, so that's it for our blocks with attributes loading into database. I'll see you in the next video.